Here is a situation that is becoming increasingly common on modern software teams, and it is one that QA engineers are not always prepared for. A developer uses GitHub Copilot or a language model to generate a function, an API handler, or an entire component. They review it briefly, it looks reasonable, it passes a basic smoke test, and they commit it. The pull request lands in your queue. The code works in the obvious happy path scenarios. But AI-generated code has specific failure patterns that are fundamentally different from code a human writes from scratch. It tends to handle the obvious and common cases very well. It tends to miss the subtle ones, the edge cases that are specific to your business rules, the constraints that are particular to your system, the authorization logic that depends on your internal permission model. Testing AI-generated code requires a specific mindset and a specific set of habits, one that assumes the code may be confidently wrong in ways that are not immediately obvious from a code review. In this episode, we are going to cover exactly how to approach this challenge. What to look for first, how to structure your test strategy for AI-generated code, and how to use AI tools to help you test AI-generated code through a technique called adversarial review. Yes, using AI to test AI is a real and practical workflow. Let's get into it. The key insight about AI-generated code, the one that should shape your entire approach to testing it, is this. These models are trained to produce code that looks correct, not necessarily code that is correct. Those two things are often the same, but not always. AI models are exceptionally good at pattern matching. They have processed millions of code examples across thousands of common programming patterns. Authentication flows, data validation, pagination, sorting algorithms, API wrappers. They reproduce these patterns reliably and fluently. The code is syntactically correct, it follows naming conventions, it handles the common cases in the expected way. Where the model breaks down is in the specifics. The business rule that is slightly different from the standard pattern it learned from. The edge case that only exists in your system and is documented in an internal specification the model has never seen. The authorization logic that depends on your particular role hierarchy rather than a generic permission model. The constraint that a product manager mentioned in a planning meeting and never wrote down anywhere public. As a QA engineer testing AI-generated code, your primary job is to hunt specifically for the places where the generic pattern the model learned diverges from the specific requirement your system actually needs. You are not testing whether the code follows common patterns. It usually does. You are testing whether it correctly implements your specific requirements, and that distinction changes everything about where you focus your attention. There are 4 specific areas to prioritize when you are testing AI-generated code, because these are the areas where it is most reliably wrong in ways that are hard to catch through code review alone. The first area is boundary conditions. AI models implement boundary checks based on common conventions and the examples they were trained on, not based on your specific business requirements. If your spec says the maximum file size is 25 megabytes and the model generated a check for files larger than 50 megabytes, that is a business logic error that looks completely reasonable in a code review. Always test at the exact boundary values specified in your requirements document, not just the values that make intuitive sense in general. The second area is error handling completeness. AI-generated error handling often looks thorough but is not. The model handles the exception types it recognizes from its training data and silently swallows or mishandles the ones it does not. Test every error path in the specification and verify that the error response format matches your requirements exactly. The third area is permission and authorization logic. This is the highest risk area in AI-generated code because authorization rules are deeply system-specific. The model does not know your permission model. Test every role, every permission boundary, and every edge case in your authorization system explicitly. Do not assume that because the happy path works for an admin user, the access restrictions work correctly for a read-only user. The fourth area is data type assumptions. AI-generated code frequently assumes input types that may not match what your system actually sends. Let me walk through a concrete example that illustrates exactly how this failure mode shows up in practice. A developer on your team uses Copilot to generate a function that calculates the final price after applying a user's membership discount. The function takes the user's membership tier and the original cart total and returns the discounted price. The developer looks at the generated code, the logic seems sensible, the structure is clean, and they commit it without changes. The pull request arrives in your queue. You look at the implementation and notice that Copilot implemented the discount as a percentage. 10% off for silver members, 20% off for gold members. That is a perfectly reasonable implementation for a generic discount system. But your product requirements specify a fixed dollar amount per tier. Silver members get $5 off. Gold members get $15 off. The AI-generated plausible, well-structured code that is completely wrong for your actual business rule. A test that simply verifies the output is lower than the input would pass this. A test that verifies the exact expected output for a known input against your requirements would catch it immediately. The pattern to take from this example is not that AI makes mistakes. Of course it does. The pattern is that your test cases need to verify against the specific values in your requirements, not against general or intuitive correctness. When you write tests for AI-generated code, always derive your expected values from your specification, not from what the code does. Here is an advanced technique called adversarial review that is worth adding to your workflow for any pull request containing significant AI-generated code. Before you write your tests, paste the AI-generated function into a language model along with the requirements it is supposed to implement. Ask the model to compare the implementation against the requirements and identify any discrepancies. Ask it specifically to look at the boundary conditions, the error handling completeness, and any assumptions the code makes about input data that might not hold in your system. Ask it what scenarios the implementation does not handle. The model is often surprisingly good at spotting these kinds of gaps in another model's output, precisely because it approaches the code fresh, without the assumptions and context the developer had when they accepted the Copilot suggestion. This technique is sometimes called using AI to review AI, and in practice it works as a fast first pass that surfaces a prioritized list of areas to focus your testing on. It does not replace your test strategy. It informs it. Running this kind of adversarial review takes about 5 minutes and consistently surfaces at least one issue that would otherwise require a production incident to discover. The return on that 5 minutes of investment is very high. Testing AI-generated code is not fundamentally different from testing any other code. The core principles are the same. Test against your specific requirements. Cover every boundary condition in the specification. Verify every error path. Check every permission boundary. What is different is the failure mode you are optimizing for. Human-written code tends to fail at the complex and the unfamiliar. AI-generated code tends to fail at the specific, the business rule-dependent, and the system particular. It gets the common pattern right and misses your specific implementation requirement. Knowing that failure mode changes where you direct your attention when you review the code and when you write your tests. Test the exact values from your specification. Run an adversarial review using an AI tool before you write your tests. Test every permission boundary explicitly. Test every documented error path and verify the response format matches your requirements. Build these habits into your pull request review process for any team that is using AI tools to generate code, because the volume of AI-generated code in most teams is increasing and the test strategy needs to keep pace. In the final episode of this series, we are going to bring everything together into a complete, practical, daily workflow. How all the tools and techniques we have covered fit into a coherent process you can actually follow every day. Subscribe so you do not miss it.